Imagine an actor starring in different movies, same person, but a new role and behavior each time. That's exactly how polymorphism works in object-oriented programming. Same method behaves differently based on the object calling that method.
As we understood from the video, polymorphism means many forms or behaviors. For example, same actor playing the different roles. Polymorphism in object-oriented programming means allowing one interface, which could be method, function, or operator, to behave differently based on the object calling that interface or the data type which is input to that interface. Let's understand about the polymorphism in detail in next slide. In this video, we will discuss which are the different types of polymorphism, and then we will focus more on compile-time polymorphism and understand the different subtypes of compile-time polymorphism. Types of polymorphism. There are two types of polymorphism, compile time and runtime. Compile time polymorphism is achieved by method overloading and operator overloading. Runtime polymorphism is achieved by method overriding and dynamic method dispatch working together. Let's understand about the compile time polymorphism. Compile time polymorphism means behavior is already defined in a code and same gets converted to machine code for execution. It means that whatever interface which we want to behave differently based on the object calling it or based on the input data type to that interface, that behavior of that interface, the different behaviors of that interface is already defined in the code, right? And the function call logic, basically the connection between the function call or the interface call and the definition of that interface is set when the program is being prepared for running. So compiler is already aware of that whatever the function call or the interface call is happening in the code, it is connecting to which behavior. So that compiler is already aware of. That is why it is called as a compile time polymorphism, or also known as a static binding. Right? That binding between the function call logic and the definition of the function defined in the code is known before actually program executes. Let's understand the different types of compile time polymorphism. One is method overloading. Multiple methods with the same name but different parameters. So in method overloading, there are multiple methods with the same name, but the parameters of each method will be different. The compiler determines which method to call at compile time based on the method signature. As I explained in a previous slide, compiler is already aware of the connection between the method called and the definition of the method, right? So because the method signatures are different for that multiple methods, so compiler is already aware of it while compiling the code or building the code. Let's understand with the example. Here, if you see the class math operations, you can see there is a method called add here. So the first overloaded method add is receiving the two parameters of type int. Then the second overloaded method of the same name add, which is receiving two parameters of data type double. And there is a third method with the same name add. It is receiving three parameters of type int, right? So this is the different behavior of the same method, right? The method with the same name. This is one behavior, second behavior, and the third behavior. So when the call happens in a code, compiler already aware of based on the method signature. Okay, this is passing the two parameters of type int, so it will be connected to this first method. So compiler is already aware of it. So this method call and the definition of the method, that connection is already there, right? It is basically, we can see that is already defined in a code. So this is known to the compiler. Similarly for the second method and the third method. So this is why the compiler knows it, because it is already statically defined that for each method, how many parameters are there, which type of parameters are there. So this is predefined in a code. So based on the method call, it is connecting to the which overloaded method that is already defined, right? So this is the method overloading part. Now let's understand another example where we also call it as a constructor overloading. So you can see two constructors, one with the one parameter and second constructor with the two parameters. So when the first constructor is called here with just one parameter, it will call the first constructor, and the second constructor, second call here with the two parameters passed, so it will automatically connect to this the second constructor with the two parameters, right? So this is also one of the example of method overloading. In method overloading, method return type does not matter or considered in a method overloading. Let's understand why. For example, if we have this class math operations where the same name, multiple methods are there with the same name add, right? But here the parameters, the number of parameters is same. The type of the input parameters is also same in both of the functions, right? Only the return type is different. Now, if we write the code like this, like create the object of math operations class and call the add method. Here, if you see, we are not assigning any this value to any variable, right? So we are ignoring the return type here, and this we can, depending on the logic, we can write like this, like we might ignore the return type, right? So when we do that, compiler gets confused now because it is not assigned to any type of variable. So compiler could not evaluate which add method to call, right? Because we are ignoring the return type, and the parameters of both the methods are same in number, the data type, order, everything is same. So the compiler gets confused and it gives the error related to ambiguity, right? That it is not able to decide which add method to call. So that's why the return type is not considered in a method overloading. The second part of the compile-time polymorphism is the operator overloading. As the name suggests, it allows the operators like plus, minus, etc. to have a different behaviors based on the operands they are used with. Same operator can perform different tasks depending on the data type of the operands, right? Let's understand these two sentences with example. If you see the example here, the plus operator, right? If you use that with 10, 20, this is operands, integer type, right? It will do the addition and give the 30 as a output. But if you use the same operator plus with the string operands, the operands are basically the input on which that operator is active. So hello and world, these operands, if they are string, it will do the string concatenation. So we can see the different behavior of the plus operator, right, based on the operands and their data type. Now, one thing to note here is that Java does not support the custom operator overloading, right? What are the operator overloading functionality available in Java like this for plus operator? It is very limited, right? So Java does not support the custom operator overloading. That's why we will check the operator overloading using the C++ example. We'll understand using the C++ example. For example, here there is a class called complex, and you can see how the operator overloading for plus operator done here, right? It is defined like this with the operator keyword and the operator, right? Plus, minus, whichever operator we want to overload. And in that function, we can have our custom logic or the overloaded logic, right? Now, here we created the complex object C1 and C2. Now, when we do C1 plus C2, right, it is using the overloaded plus operator, which is defined for this complex class. It is basically depending on the object calling, right? Here the complex object is calling, so it will check the overloaded function, operator overloaded function in this complex class, right? And it will, what it is having some custom logic is that it will do the addition of the real variable in both the objects and the imaginary variable of both the objects and return the new object, complex object, and it will be assigned to the C3, right? And we can see the output is basically 2 plus 4 6 and 3 plus 5 8. What are this display function is outputting. This is the operator overloading, which is done in a C++ using operator keyword. Right? Java does not have the custom operator overloading support. Java provides some methods like add and different methods for us, but there is no operator overloading, custom operator overloading functionality available. So compile-time polymorphism is not supported by all the languages, right? For example, the languages like Python, where the type resolution happens dynamically, this compile-time polymorphism cannot be achieved because uh, to happen the compile-time polymorphism to come into the picture, right? There needs to be some compile time or the that compilation step needs to come into the picture. But Python does not have that. Right? It does all the things dynamically. And similarly, the languages which have such dynamic typing, they do not support the compile time polymorphism. Hope you understood the explanation. We understood the polymorphism definition with real life example, and then we understood the different types of polymorphism, which are compile time polymorphism and runtime polymorphism. Then we focused our discussion on compile time polymorphism and the subtypes related to the compile time polymorphism, like method overloading and operator overloading, and in which case the compile time polymorphism is supported. In the next video, we'll understand about the runtime polymorphism and why polymorphism is important and when to avoid the polymorphism in detail. If you like the video, please share and subscribe. Thank you so much.